Hey there, meet Nikki. Nikki wants to check whether 22 and 11 are zeros of the quadratic polynomial x squared minus 33x plus 242. One way to verify this is by substituting these values in p of x and then checking whether its value is 0 or not. Alternatively, we can verify the same using the relationship between the zeros and the coefficients of the given quadratic polynomial. Let's see what the relation is. The general form of any quadratic polynomial is ax squared plus bx plus c. Now let's assume its factorized form is k times x minus l multiplied by x minus m, where k is a constant and l and m are zeros of the quadratic polynomial. When we expand the right hand side, we get. Now, let's compare the coefficients of the terms on both sides of the equation. The left-hand side coefficient of x squared is a, and the right-hand side coefficient of x squared is k. Thus, k is equal to a. Similarly, the right-hand side coefficient of x is minus k times l plus m, and the left-hand side coefficient of x is b. Thus, b is equal to minus k times l plus m. But k is equal to a. Therefore, L plus m is equal to minus b over a. In the same way, on the right hand side, the constant term is klm, whereas on the left hand side, the constant term is c. Therefore, c is equal to k times l times m. Taking k on the other side, we get. In a quadratic polynomial, the sum of zeros is the negative ratio of the coefficients of x and x squared, and the product of zeros is the ratio of the constant term and the coefficient of x squared. Now let's use this concept to solve Nikki's problem. In this quadratic polynomial, a is equal to 1, b is equal to minus 33, and c is equal to 242. Let's assume the factorized form of the polynomial be k times x minus l multiplied by x minus m. For this quadratic polynomial, the sum of the zeros should be minus b by a. The product of the zeros should be c by a. Let's verify this with 22 and 11. Hence, we have verified the relationship between the coefficients and the zeros through this example. Easy, wasn't it? Well, that's all for the day. See you next time then.